If we imagine that the square root of -1 has a value, then we can essentially evaluate any square root of a negative number, using surds in the usual way. We say that the square root of -1 is the imaginary number, and we denote it using the letter I. A complex number is of the form shown. The real number A is called the real part of the complex number, and the real number B, multiplying the imaginary number, is called the imaginary part. Notice that both A and B are real numbers. We can add and subtract complex numbers by dealing with like terms. We first add together the real parts. Then we add together the imaginary parts. This gives us the complex number. Look at the example. See how we first add the 2 and the 3 to obtain the real part, and then add the 2 and the 5 for the imaginary part. Now try the question.
We can also multiply complex numbers. We do this in a similar way to expanding the brackets when multiplying polynomials. Take the real part of the first complex number and multiply it by the real part of the second, and multiply it by the imaginary part of the second number. Then take the imaginary part of the first complex number and do the same again. Then we simplify by gathering like terms and remembering that I squared is -1. Before looking at dividing complex numbers, we need to know what the complex conjugate is. To find a complex conjugate, we basically change the sign in front of the imaginary part of the complex number. It's as simple as that. The best way to explain dividing complex numbers is using an example. The first step is to multiply both the numerator and the denominator by the complex conjugate of the denominator. In this case, it's 2 plus I. Then all we have to do is simplify.
We can also represent complex numbers geometrically on an Argand diagram. The x-axis represents the value of the real part of the complex number, and the y-axis represents the imaginary part. These prove useful when finding the roots of unity. What is the cube root of 1?
1?
This is right, but there is more than just one cube root of 1. There are 3, and on the Argand diagram we can see them in the following way. Imagine a unit circle around the origin. Now take an equilateral triangle with one of the points at 1, 0. Where each of the corners meets the unit circle, we have a cube root of 1, and collectively they are the cube roots of unity. We can do this with any regular n-sided shape to geometrically describe the nth roots of unity.